Today we're going to be talking about horizontal and vertical translations. So transformations that shift a function up, down, right, or left without affecting the shape are called translations. The first thing that we're going to be talking about right now is a vertical translation, so shifts up and down. So the graph of the function g of x equals f of x plus c is a vertical translation of the graph f of x. So this plus c is what's most important right now. For these examples, I'm just going to be using our base function x squared or parabola. I think that's just easiest for you to visually see what's happening as we go along. So I have my f of x is equal to x squared. Now, my first translation that I'm going to be talking about is g of x is equal to f of x plus 2. Now this plus 2 is my c, and that basically means that every single key point in our x squared needs to be shifted up 2 units. So all of these points, or this entire graph, is going to be shifted up 2. My next graph that I'm going to be doing, and I'm just again picking a different equation to give you, is going to be g of x equals f of x minus 4. So you notice this time, now my c value is a negative 4. As I think you're probably assuming, that does mean that this graph moves down 4 units. So I'm going back to my original base function, my f of x equals x squared, and I'm going to be shifting all of those points down 4 units. So now this green graph is my new g of x. Like I mentioned, you can do this for any base function. So I'm just going to draw this in really quick. You probably don't even need to draw this in your notes. But if I have my base function square root of x, and I then said that I needed to do f of x plus 3, my graph would look the exact same, except it needs to be shifted up 3 units. For this next example, again, I'm going to be using a base function of x squared. F of x is equal to x squared. Now, this example is going to be talking about horizontal translations. So if you look here, the graph of the function g of x equals f of x minus d. Notice how that d is now in the brackets with the x. That is how you're going to identify that it is a horizontal translation versus the vertical translation, which was the plus c that we saw outside of the brackets on the previous slide. So for my first example, I'm going to be doing g of x is equal to f of x minus 1. Now what that's going to look like is every single point on this graph needs to be shifted to the right 1 unit. Now some of you are probably thinking, whoa, why is this going to the right? And that is because, for the same reason as every time we're talking about moving quadratics or we're thinking about the vertex or anything like that, when something is in brackets, we need to imagine the opposite signs. And that is because of this x minus d that we have up here in the original equation. So really, this d value is only a positive 1 because the negative that I see here is just part of the question. So really my d value is a positive 1, which does mean a shift to the right. So even though it looks negative, it's positive. The next example that I'm going to be doing is g of x is equal to f of x plus 3. Now you guessed it, this does mean a shift to the left 3 units. So my graph will look like this. That looks a little wide. It probably should not be that wide, but you get the point. Every single point needs to be shifted left 3 units. So in this example, I'm giving you the graph of any relation. This specific one just happens to look like a check mark. So the graph that's shown below is f of x. And I'm asking you to sketch a graph g of x by determining image points. So an image point is any point that has been transformed from the original. So you're going to notice that I'm going to be using a prime, or it looks like a little apostrophe next to each letter to represent an image point. So the graph that I'm going to be asking you to graph is going to be Gx is equal to f of x plus 2. So we know by now that this is a plus c, so we know that this is a shift up 2 units. So every single one of these points needs to be shifted up 2. Now visually, I could see that this one's going to be moving here, this one is going to be moving here, this one's going to be moving here, and this one's going to be moving up here. And so my graph will look like this. Now, if I asked you to write those image points, we would write them like this. So the first one's going to be written as A prime because this is representing an image point. So the point A has moved to the following point. Now, it used to be at 0, 1. Now, if I'm moving it up 2, I know that it's going to be at 0, 3. Same thing for B. B used to be at 1, 0. I'm not changing the shift right or left. All I'm doing is changing the up and down. I'm shifting it up 2. So B prime is going to be equal to 1, 2. C prime, so C used to be 3, 2. I'm shifting it up 2. So my new C is going to be 3, 4. I take the 2 and the y and I've added 2 to it to get to 4. And D prime is going to be at 5, 6. It used to be at 5, 4. I've shifted it up 2 units. I could do the exact same thing. I could ask you to graph g of x is equal to, let's see here, f of x minus 3. Now what we know is this is a shift right 3 units, so everything needs to be shifted right 3, and it would look like so. I could write those image points the same way. This time I'm going to be adding 3 to the x because I'm talking about a shift right 3. The last example that we're going to be going through today is describing transformations that are taking place. I'm also going to be talking about what kind of base functions we're dealing with, just because it's a really good habit to start thinking about that, even if the question doesn't specifically ask you for that. So for each function, describe the transformations. Here's A, g of x is equal to x plus 5 squared plus 1. Now, right away, I can see that this is a base function. F of x is equal to x squared. Now I know this because I see this squared, and the quadratic is the only base function that has an exponent like that in it. Now I can start talking about my transformations. The first thing that I see if I'm looking left to right is the x plus 5 in the brackets right there. So right away I recognize that I have a d value of negative 5. I see a plus 5, I know that my d is the opposite, so I know that my d is negative 5, which means that I have a shift or a translation 5 units to the left. So I'm just going to write this right here. Translation 5 units left. Now the next thing that I'm going to see is this plus 1 at the end. So right away, since it's outside of the brackets, I know that this is my C, and I know that if my C is 1, then it means that I have a translation 1 unit up. This next example is a base function of, let me just write this down here, f of x is equal to 1 over x. Now again, I see a division sign right here, so I know right away that this has to be my base function. This one is a little bit more difficult to see because I don't see any brackets. Technically, I could have brackets right here that might help you in determining what your D and what your C are. If you don't need them in there, don't put them in there. Some people just will benefit from them. So the first thing that I'm going to be noticing is this x plus 3 right here. So right away, I can tell that my D value is equal to, again, it has to be opposite, negative 3. So right away, I know that I have a translation left 3 units. And I'm really sorry about this writing, guys. I broke my stylus pen, and the next one is not expected to come for a couple weeks. So I'm really hoping that I learn how to write with my finger a little bit better. The next thing that we're seeing right here is a minus 7. So I can recognize that my C is equal to negative 7, which means that I have a translation down 7 units. The third and final example that I'm going to be going through today is g of x is equal to the square root of x minus 2 plus 4. So right away, I can tell that my base function is f of x is equal to the square root of x. Again, I have no base functions other than the square root of x that have a square root in them. The first thing that I'm going to be noticing is right here, this negative 2. That is my D value. Again, there are no brackets in here, but there could be. So my D value is the opposite one. So my D is equal to positive 2, and that means that I have a translation right 2 units. The plus 4 at the end tells me that my C is equal to plus 4, which tells me that I have a translation up by 4 units.